for the installation of an 800 amp panel board on the load side of a 480 volts to 208 volts UPS system fed from an external manual bypass panel containing 3 800 amp breakers. You can indeed use a main lug only or MLO panel board for the 800 amp panel. This configuration is permissible because the 800 amp panel will be located downstream of both the 480 volts to 208 volts UPS system and the external manual bypass panel. Consequently, it does not necessitate a main breaker within the 800 amp panel itself. The external panel, with its complement of 800 amp breakers, functions as the primary point of disconnect for both the UPS system and the downstream 800 amp panel. To elaborate, the fundamental role of a main breaker within a panel board is to furnish a singular point of disconnection for all circuits originating from that panel. However, in this specific scenario, the 3 800 amp breakers housed within the external panel already fulfill this critical function. They provide the means to disconnect the entire 800 amp panel from the upstream power source. Therefore, incorporating an additional main breaker within the 800 amp panel would be redundant and unnecessary. MLO panel boards find frequent application in situations precisely like this one, where an external disconnect mechanism is already in place. They offer a practical and economically viable approach to distributing electrical power to downstream circuits without incurring the expense or complexity of integrating an additional main breaker. The selection of an MLO panel board over a main breaker panel board in this context yields several advantages, particularly in terms of cost savings and simplification of the electrical system. Firstly, MLO panel boards typically exhibit a lower initial cost compared to their main breaker counterparts. This cost differential arises from the absence of the main breaker component, which can represent a significant portion of the panel board's overall expense. Secondly, the elimination of the main breaker simplifies the wiring and installation process. With an MLO panel board, there are fewer connections to make and less internal components to manage, potentially reducing installation time and labor costs. Thirdly, the presence of an external disconnect, such as the manual bypass panel in this case, provides a readily accessible means of disconnecting the entire panel board from the power source. This can be particularly advantageous during maintenance or troubleshooting activities, as it allows for a safe and convenient way to de-energize the panel board without having to access the panel board itself. Furthermore, the use of an MLO panel board in conjunction with an external disconnect can enhance the overall safety of the electrical system. By providing a separate and independent means of disconnecting the panel board, it reduces the risk of accidental energization during maintenance or repair work. It is important to ensure that the external disconnect is properly sized and rated to handle the full load of the panel board, and that it is readily accessible to authorized personnel. In addition to the cost savings and simplification benefits, the use of an MLO panel board can also improve the reliability of the electrical system. By eliminating the main breaker, it removes a potential point of failure in the system. Main breakers, like any other electrical component, can fail over time due to wear and tear, corrosion, or other factors. By using an MLO panel board, you reduce the risk of a main breaker failure disrupting power to the downstream circuits. However, it is crucial to emphasize that the selection and application of electrical equipment, including panel boards and disconnects, must always adhere to the applicable electrical codes and standards. These codes and standards are designed to ensure the safety and reliability of electrical systems, and they provide specific requirements for the installation, wiring, and protection of electrical equipment. For instance, the National Electrical Code, or NEC, contains comprehensive guidelines for the selection and installation of panel boards, including requirements for overcurrent protection, grounding, and conductor sizing. It is essential to consult the NEC and any other relevant codes and standards to ensure that the installation of the 800 amp panel board complies with all applicable requirements. Furthermore, it is imperative to engage qualified and licensed electrical professionals for the design, installation, and inspection of electrical systems. Electrical work can be inherently dangerous, and it is crucial to have trained and experienced personnel performing the work to ensure that it is done safely and correctly. Licensed electricians have the knowledge, skills, and experience necessary to select the appropriate equipment, install it properly, and verify that it meets all applicable code requirements. They can also identify potential hazards and take steps to mitigate them, ensuring the safety of the electrical system and the people who use it. In addition to adhering to electrical codes and standards, it is also important to consider the specific requirements of the UPS system and the external manual bypass panel. The UPS system may have its own specific requirements for the connection of downstream loads, and it is essential to follow these requirements to ensure the proper operation of the UPS system. The external manual bypass panel should also be properly labeled and documented to indicate its function and the circuits that it controls. This will help to ensure that authorized personnel can quickly and easily disconnect the panel board from the power source in the event of an emergency or for maintenance purposes. When selecting an MLO panel board, it is important to choose one that is appropriately sized for the load that it will be serving. The panel board should have sufficient capacity to accommodate all of the circuits that will be connected to it, and it should be rated for the voltage and current that will be present in the system. It is also important to choose a panel board that is suitable for the environment in which it will be installed. For example, if the panel board will be installed in a damp or corrosive environment, it should be rated for that environment. In summary, the use of an MLO panel board for the 800 amp panel in the scenario is permissible, provided that the external manual bypass panel provides a suitable means of disconnecting the panel board from the power source. It is essential to adhere to all applicable electrical codes and standards, and to engage qualified and licensed electrical professionals for the design, installation, and inspection of the electrical system. By following these guidelines, you can ensure that the electrical system is safe, reliable, and compliant with all applicable requirements. Remember to always prioritize safety when working with electrical equipment and to take the necessary precautions to protect yourself from electrical shock and other hazards. Electrical work should only be performed by qualified and licensed professionals who have the training and experience necessary to do the work safely and correctly. In addition to the points already covered, there are a few other considerations that may be relevant to the installation of the 800 amp panel board. Firstly, it is important to ensure that the conductors that feed the panel board are properly sized and protected. The conductors should be sized to carry the full load of the panel board, and they should be protected by overcurrent devices such as fuses or circuit breakers that are sized to protect the conductors. The size of the conductors and overcurrent devices should be determined in accordance with the NEC and any other applicable codes and standards. Secondly, it is important to ensure that the panel board is properly grounded. Grounding is essential for safety, as it provides a path for fault current to flow back to the source, which helps to trip over current devices and prevent electrical shock. The panel board should be grounded in accordance with the NEC and any other applicable codes and standards. Thirdly, it is important to ensure that the panel board is properly labeled. The panel board should be labeled with the voltage, current, and phase of the system, as well as the size and type of overcurrent devices that protect the circuits that are connected to the panel board. The labeling should be clear, concise, and easy to read, and it should be in accordance with the NEC and any other applicable codes and standards. Fourthly, it is important to consider the ambient temperature in the area where the panel board will be installed. The ambient temperature can affect the ampacity of the conductors and the rating of the overcurrent devices. If the ambient temperature is high, it may be necessary to derate the conductors and overcurrent devices to prevent them from overheating. The derating factors should be determined in accordance with the NEC and any other applicable codes and standards. Fifthly, it is important to consider the potential for harmonics in the electrical system. Harmonics are distortions of the voltage and current waveforms that can cause problems with electrical equipment, such as overheating, reduced efficiency, and premature failure. If the electrical system is likely to have harmonics, it may be necessary to install harmonic filters to mitigate the effects of the harmonics. The need for harmonic filters should be determined by a qualified electrical engineer. Finally, it is important to keep accurate records of the installation. The records should include the date of installation, the name of the installer, the model and serial number of the panel board, the size and type of conductors and overcurrent devices, the grounding method, and any other relevant information. The record should be kept in a safe place and should be readily available for future reference. By considering these additional factors, you can help to ensure that the installation of the 800 amp panel board is safe, reliable, and compliant with all applicable requirements. It is always best to consult with a qualified electrical engineer or electrician to ensure that the installation is done correctly. Now let's delve deeper into specific aspects related to your installation scenario. Considering the 480 volts to 208 volts step-down transformation via the UPS, it's crucial to verify the impedance of the transformer within the UPS. This impedance plays a role in determining the available fault current at the secondary 208 volt side. A higher impedance limits fault current, while a lower impedance allows for higher fault current. This available fault current is critical for selecting appropriately rated overcurrent protection devices, including the breakers in the manual bypass panel and any downstream circuit breakers within the 800 amp panel, if any are present. The interrupting rating, measured in amps, of these breakers must be sufficient to safely interrupt the maximum potential fault current. Failure to do so could result in breaker failure during a fault, leading to equipment damage and potential safety hazards. Therefore, a short circuit study might be necessary to accurately determine the available fault current and select suitable breakers. Regarding the external manual bypass panel, ensure its construction complies with relevant standards such as Underwriters Laboratories, or IL 891 for dead front switchboards. This standard covers the safety requirements for switchboards, including enclosure integrity, busbar spacing, and insulation. Verify that the bypass panel is properly labeled with voltage, current, and short circuit current rating. This information aids in safe operation and maintenance. Consider the coordination of a current protection between the upstream breakers in the bypass panel and any downstream breakers in the 800 amp panel. Selective coordination ensures that only the breaker closest to the fault trips, minimizing disruption to the rest of the system. Time current curves, provided by breaker manufacturers, are essential tools for analyzing coordination. These curves illustrate the tripping characteristics of breakers under different fault current conditions. Proper coordination minimizes nuisance tripping and ensures system stability. When selecting the MLO panel board, pay attention to the busbar material and ampacity. Copper busbars offer superior conductivity compared to aluminum, but are also more expensive. Ensure the busbar ampacity matches or exceeds the calculated load demand of the panel. Also, consider the number of available breaker spaces in the panel board. Future expansion should be anticipated, and selecting a panel with sufficient spare capacity can prevent costly replacements later. Grounding and bonding are paramount for safety. The 800 amp panel board must be properly grounded to the building's grounding electrode system according to NEC Article 250. This provides a low impedance path for fault current, facilitating rapid tripping of overcurrent devices. Bonding ensures that all metallic enclosures and equipment are electrically connected, minimizing voltage potential differences and reducing shock hazards. Use appropriately sized grounding and bonding conductors, adhering to NEC tables. Consider the environmental conditions where the 800 amp panel board will be installed. If the location is prone to moisture, dust, or corrosive substances, select a panel board with an appropriate enclosure rating, such as NEM 3R or NEM 4X. These enclosures protect the internal components from environmental hazards, extending the panel board's lifespan and preventing malfunctions. When installing conductors, follow proper wiring practices, adhering to NEC Chapter 3. Use appropriate conductor types, such as THHN or XHHW, suitable for the voltage and temperature rating. Support conductors properly to prevent strain on terminations. Maintain adequate spacing between conductors to prevent overheating. Torque connections to the manufacturer's specifications using calibrated torque tools. Under-torqued or over-torqued connections can lead to loose connections, overheating, and potential failures. Inspect all connections thoroughly after installation. Before energizing the system, perform thorough testing and commissioning. Use a multimeter to verify voltage levels, phase rotation, and continuity. Perform insulation resistance testing using a megometer to check for insulation breakdown. Conduct a ground impedance test to verify the effectiveness of the grounding system. Document all test results for future reference. Create a detailed panel schedule, clearly labeling each circuit breaker with its corresponding load. This aids in troubleshooting and maintenance. Post the panel schedule near the panel board for easy access. Provide training to personnel who will be operating and maintaining the electrical system. This training should cover safe operating procedures, emergency shutdown procedures, and basic troubleshooting techniques. Regular maintenance is essential for ensuring the long-term reliability of the 800 amp panel board. Inspect the panel board periodically for signs of corrosion, loose connections, or damage. Tighten connections as needed. Clean the panel board interior to remove dust and debris. Perform insulation resistance testing annually. Keep a maintenance log to track all maintenance activities. When performing maintenance, always de-energize the panel board and follow lockout/tagout procedures to prevent accidental energization. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. If modifications or repairs are needed, use only qualified and licensed electrical contractors. Unauthorized modifications can void warranties and compromise safety. By considering these additional factors and following best practices, you can ensure that the 800 amp panel board is installed and maintained safely and reliably. Consulting with qualified electrical professionals is always recommended to address specific project requirements and ensure compliance with all applicable codes and standards.